Hello, Yarrow again, video 6 on the ZFM channel. Today is Sunday, February 5th, 2017. Just a follow-up to our previous video and a couple of explanatory notes. Then we'll give it a run at 36 volts here, and we'll see how much speed we can get out of it. The firing angle here is pretty much maximum for the arrangement that I have right now. It's about 70-75 degrees. Now, our instruments here are pretty straightforward. The computer display, the grid on the display is each square in a vertical direction is a third of the volt. It matches up very closely to the reads that we take with this clamp-on meter, and both of them seem to correlate fairly well, depending on factors, if you will. The RPM is taken with this device, which is essentially a laser tachometer, and digital tachometer works fairly well. I haven't had any issues with it. Now, we're going to take this, we're going to try to get it up to about 8,000 RPM. We'll see what happens. Around 7,200 RPM, you'll note the waveform gets a little bit unusual, and it starts accelerating. It's sprinting towards that high level. The firing rate at 8,000 is 533 fires per second, or 533 hertz, way beyond what an SSG does at about 120 fires. Just to answer that question. Anyway, let's give it a spin. It has some pretty good acceleration here. Aluminum rotor, neomagnets, ready to roll. Hopefully this will spin. You can hear it cranking up right now. Probably about 6,800 RPM. And at this point, the wave pattern is about, if you look at it, it's about 4 squares of grid, indicating about 1.2 amps. All right, this is where it starts accelerating. Let's see what we have for RPM. It's about 7,900 RPM. I think it'll probably squeeze a little bit more out, but let's do a torque test. So we're drawing about 1.2 amps. Let's see if we can get more speed. Well, we're at 8,057, 8,050 RPM. And it wants to go further, but I'm not sure what's holding it back at this point. I guess we'll find out. More to come. Thank you for watching.